Welcome to the DX Today podcast, your weekly deep dive into the AI ecosystem. I'm Rick Spair, and joining me as always is Laura.
Hey Rick, happy Sunday. And wow, do we have a story today? I have been waiting to dig into this one all week.
So let's get right into it. DeepSeek, the Chinese AI lab that shocked the world last year with their V3 model, is on the verge of releasing DeepSeek V4. And this one is a monster. We're talking about a 1 trillion parameter model, open source, under an Apache 2.0 license.
1 trillion parameters, Rick? Let that sink in for a second. And yet here's the thing that really gets me. Despite having a trillion total parameters, only about 37 billion are active at any given time. That's because of the mixture of experts architecture. So you get this massive knowledge base, but the actual compute per query is surprisingly lean.
Break that down for me a little more. How does mixture of experts actually work in practice?
Sure, think of it like a hospital with 1,000 specialists. When a patient comes in, you don't send them to all 1,000 doctors. You route them to the 16 or so who are relevant to their condition. That's what MOE does with the model's parameters. Only about 16 expert modules activate per token. So you're using 37 billion parameters instead of a trillion. Same depth of knowledge, fraction of the compute.
And that's what makes this so disruptive, because when people hear a trillion parameters, they think you need a supercomputer to run it. But DeepSeek is claiming you can run an INT4 quantized version of this model on a single RTX 5090 with 32 gigabytes of VRAM. That's a consumer graphics card.
A consumer card. And for reference, Claude Opus runs on Anthropic's cloud infrastructure. GPT-5.4 runs on Microsoft Azure's data centers. And here's DeepSeek saying you can run something competitive with those on hardware you can buy at Best Buy. That changes the entire economics of this industry.
Now let's talk about the benchmarks, because that's where things get really interesting and also a little controversial. DeepSeek is claiming 90% on human evil for code generation and over 80% on SWE bench verified.
Those numbers are huge if they hold up. For context, Claude Opus 4.5 currently holds the SWE bench verified record at 80.9%. GPT 5.4 is around 80%. So DeepSeek V4 would be right in that same league. But, and this is a big but, these are internal benchmarks from DeepSeek's own testing. We haven't seen independent verification yet.
And that's an important caveat. We saw this before with DeepSeek V3, where the initial claims were impressive, and then independent testing showed a more nuanced picture. So I'd say be excited, but verify.
Absolutely. But even if V4 comes in a few points below those claims, the pricing changes everything. We're talking estimated API pricing around 30 cents per million tokens. Compare that to GPT-4o at $250 per million or Claude Opus at $15 per million tokens. That's a 50x cost difference versus Opus.
50 times cheaper. That's not an incremental improvement. That's a completely different business model. And it forces every AI company to answer a really uncomfortable question. How do you justify premium pricing when a comparable model costs a fraction of the price?
Well, and this is where it gets nuanced. Comparable on benchmarks doesn't mean comparable on everything. Claude has real strengths in multi-file reasoning and understanding developer intent. GPT 5.4 has those steerable reasoning controls and computer use capabilities. Benchmarks capture one dimension of performance, but developer experience is multi-dimensional.
That's a fair point. But for a lot of use cases, especially in development shops and startups, good enough at 1/50th, the cost is going to win every single time.
100%. And there's another angle here that I find fascinating, the Ngram conditional memory system. This is DeepSeek's innovation for handling the 1 million token context window, and it's achieving 97% accuracy on the needle in a haystack retrieval test at that scale.
97%. What do other models get at that context length?
Standard attention mechanisms hit about 84% at the same million token scale. So this is a 13-point improvement in retrieval accuracy, which sounds incremental, but in practice is the difference between reliably finding information in a huge code base and missing critical details.
So you can feed it an entire code base, essentially 20 novels worth of text, and it can find and reason about specific details with 97% accuracy. That's a genuine architectural breakthrough.
It really is. And the way they did it is clever. They call it conditional memory because the model learns to conditionally activate different memory pathways depending on the query. So instead of trying to attend to everything all at once, which is computationally insane at a million tokens, it has these learned shortcuts that route attention where it's most needed.
That sounds like it could have applications well beyond just DeepSeek's model.
Oh, absolutely. If the Ngram paper holds up to peer scrutiny, I expect every major lab to be integrating similar techniques within 6 months. This is the kind of architectural innovation that lifts the entire field.
Now let's talk about the geopolitical elephant in the room. DeepSeek v4 was trained entirely on Chinese-made chips, Huawei Ascend 910B processors, and Cambricon MLU chips. No NVIDIA hardware whatsoever.
And this is a direct consequence of U.S. export controls. The idea behind those restrictions was to slow down China's AI development by cutting off access to the most advanced chips. And yet, here we are. DeepSeek is building a trillion-parameter model that's competitive with the best American models on domestic hardware.
It raises real questions about whether those export controls are achieving their intended goals or if they're actually accelerating China's development of independent chip capabilities.
I think the answer is both, Rick. The export controls probably did slow things down. DeepSeek v4 has been delayed multiple times due to what they described as hardware adaptation issues and chip interconnect bandwidth challenges. Those delays are real and measurable, but the end result is that China now has a more self-sufficient AI supply chain, which was exactly the outcome the controls were supposed to prevent.
A classic case of unintended consequences in tech policy.
Exactly. And the training cost is another mind-bending number. DeepSeek reportedly trained v4 for about $5.2 million. Compare that to the hundreds of millions, some estimates say over $1 billion, that frontier labs in the US are spending on training runs for their top models.
$5 million for a trillion-parameter model. How is that even possible?
It comes down to the MOE efficiency and some very clever engineering. With mixture of experts, you're only training a fraction of the model at any given time. And DeepSeek's team has developed techniques like the manifold constrained hyperconnections, or MHC, which stabilize training at this massive scale. So you avoid the failed training runs and wasted compute that plague other large-scale efforts.
Let's talk about the open source angle because I think this is where the real disruption lies. Apache 2.0 license on a trillion parameter model. That means anyone can use it, modify it, build commercial products on it with essentially no restrictions.
There is nothing else like this in the open source world at this scale. Meta's Llama models are great, but they come with usage restrictions above certain thresholds. Mistral has been moving toward more permissive licensing, but hasn't hit this scale. DeepSeek v4 under Apache 2.0 is genuinely unprecedented.
And what does this mean for the AI industry broadly? If v4 delivers even close to what's claimed, does it undermine the entire API-based business model that companies like OpenAI and Anthropic are built on?
That's the trillion-dollar question. Literally, I think it forces a bifurcation in the market. For straightforward tasks, code completion, document processing, translation, summarization, an open source model that's nearly as good at a fraction of the cost is going to pull a lot of volume away from the commercial APIs.
And for the premium use cases?
That's where OpenAI, Anthropic, and Google can still compete. Enterprise reliability, safety guarantees, specialized fine-tuning, integrated tooling, customer support. Those things have real value, but the margin pressure is going to be enormous. We could see significant pricing adjustments across the board.
Now, we should talk about v4 Lite, which actually dropped on March 9th as a sort of preview. 200 billion parameters. What did we learn from that release?
v4 Lite was essentially a proof of concept for the new architecture. It validated that the Ngram memory system and the MHC training approach work at scale. Performance was solid, but not frontier level, which is expected for a model that size. The real signal was that the underlying technology is ready.
So the full v4 release is more of an engineering challenge than a research problem at this point?
Exactly right. The science is proven. Now it's about scaling it up on the hardware they have available and getting the distributed training infrastructure working smoothly across those Huawei and Cambricon chips.
And the timeline for the full
DeepSeek has been cagey about exact dates, understandably given how many previous windows they've missed. But all signals point to April 2026. We could literally see it any day now. Some insiders are saying it could drop within weeks, possibly even days.
When it does drop, what should people be watching for?
3 things. First, independent benchmark verification. Do the claimed SWE bench and human eval numbers hold up when tested by third parties? Second, the multimodal capabilities. V4 is supposed to have native text, image, video, and audio processing baked in from pre-training, not bolted on after the fact. That could be a game changer if it works well. And third, real-world deployment experience on consumer hardware. Does it actually run well on an RTX 5090?
Those are great watch points. I'd add a fourth, which is the safety and alignment story. With a model this powerful being released open source, the safety community is going to have a lot to say about whether this is responsible.
That's a really important point. The debate around open sourcing frontier-capable models has been heating up all year. Proponents say transparency and broad access make AI safer because more eyes are on the technology. Critics worry that you can't unrelease a model, and bad actors will find ways to strip out safety guardrails.
And DeepSeek, being a Chinese company, operates in a different regulatory environment. The safety norms and testing protocols may not align with what Western researchers and policymakers expect.
Exactly. And this is where the global AI governance conversation gets really complex. You have a model that could match the best in the world, available to anyone with an internet connection, trained outside the reach of US or EU regulation. The existing governance frameworks simply were not designed for this scenario.
It feels like the AI equivalent of nuclear proliferation concerns, except the genie is already out of the bottle.
That's a strong analogy. Though I'd push back slightly and say the dual-use nature of AI models is much more weighted toward beneficial applications than weapons technology. The vast majority of people who download and run DeepSeek V4 will use it for legitimate and productive purposes. But yes, the inability to control distribution once it's released is a genuine governance challenge.
So to bring this all together, DeepSeek V4 is potentially one of the most significant AI releases we've seen. A trillion parameter model, open source, trainable for $5 million, runnable on consumer hardware, and competitive with the best closed models in the world.
If even half of what's been claimed holds up under scrutiny, it fundamentally changes the competitive landscape. It puts pressure on pricing across the industry, validates the open source path for frontier-scale models, and demonstrates that China's AI capabilities have reached a new level despite export restrictions.
And for anyone building with AI, whether you're a developer, a startup, or an enterprise, this is a model you're going to want to evaluate seriously when it launches.
Absolutely. The next few weeks are going to be very interesting. Keep your eyes on the DeepSeek release page and the independent benchmarking communities. This is going to be the biggest open source AI event of the year, and possibly the most consequential.
That's all for today's episode of the DX Today podcast. Thanks for listening, and we'll see you next time.